What's up everybody, it's Math at Home here. This is lesson 1, page 161 from your learner's book. Today we will cover unit 14, angles. But before doing so, last session we studied something about nets. So today, first we're going to be busy doing the practice part on page 161, which is related to nets. Then further on, we will study about angles. So please grab everything necessary and let's get started. Practice page 161. Question 1. Which of these polygons from page 160 can you use now to make nets for these three-dimensional shapes? Remember to say how many of each polygon is needed. Now, as we have any choices, we have a cube, triangular prism, and an hexagonal prism. What are the open nets of these three-dimensional shapes and how many of each shape do we need? I will represent a cube for you. Now, as you can see here, on a cube, we have 6 faces. So the first face is obviously this part, the front part. The second is the left side. And following that, the third is going to be the right side. Now, behind the shape is going to be the fourth one. Bottom is 5. And the top is going to be 6. Now, the main shape, as you could recognize, because of the perspective of the 3D shape, the easiest one is the front face, which is going to be a square. Okay, so how many of these squares do we need? So obviously we're going to have 6 of these squares. Following to a triangular prism. In a triangular prism, as you can see, we have one triangle on top, the other one is in the bottom. So as you could guess, these 3D shapes are somehow transparent, so you could see through, and it's easier for you to understand the different faces of them. Therefore, we're going to have, about the faces, we will have triangles, 2 of them, and about the other faces, we have, as you could see, some rectangles here. So the first one is here, which I'm pointing at. The second one is the left side, and the other one is the right side. So we will have 3 of these rectangles. Going to the other choice, which is an hexagonal prism, I will display the shape for you. Okay, this is an hexagonal prism. It's actually a prism with hexagon base. Okay, so you tell me please, how many hexagons do we have here? Brilliant. So we will have 2 hexagons, and following that, we have some rectangles. So can you please count how many rectangles we have here? Well, yes, we have 6 rectangles. Going to question 2. We can use the same polygons to make nets for other 3D shapes. Choice A. Which 2 shapes are they? Now, looking at these 2 nets, can you tell me what shapes are they going to form after we close them? Well, brilliant. The first one obviously is going to be a square-based pyramid. Now, once you fold these parts up, they unite in the center, you're going to have a pyramid, a square-based pyramid. And the second one, this shape, is going to make a tetrahedron. If you wonder what a tetrahedron is, well, I need to tell you that a tetrahedron is a triangle-based pyramid. Now, as you can see here in this pyramid, our base is square. But in this one, our base is going to be a triangle. So a triangle-based pyramid, we call it a tetrahedron. Now, part B of the same question asks, can you arrange the polygons in a different way and still make the nets for these 3D shapes? It means somehow you come up with a different idea and sort these different parts of the nets in a different order, but as we close them, we're going to form the same 3D shapes. As for the first one, we're going to end up with a square-based pyramid, and the second one is going to end up with a tetrahedron. As a help, I'm going to do the first one about the square-based. Now, if we want to draw the net in a different form, so obviously the base is going to be the same. The upper triangle is going to move just like this here. I mean this part. And the bottom one also. Okay, about the side ones, the ones that are attached next to the base, we could easily attach them to the upper and the bottom triangles. What I mean is that I could move this triangle here, and I could move the left one, this one, and attach it to the bottom one. So obviously, if I want to fold this or close the net, I will end up with the same exact shape as it was, which was a square-based pyramid. See, use your imaginations. Now, if I fold this one upwards and this one upwards too, then I can fold this one leaning to this side. It means this corner is going to attach here, and here, this corner is going to attach here. So we're going to end up with a square-based pyramid. Now about the tetrahedron, take your time and think about it. How could we rearrange the net in order to have the same shape? Well, yes. So this is this is the base, which represents this triangle. So the upper one is going to sit the same. Now the left corner is going to be the same also. But you could use this triangle in a different place. So it can actually come and sit right here. So imagine if I have the base here, this one folds upwards, this one folds upwards too, so these parts, these edges match each other. So the only face which is missing is going to be this face. Now in this case, this triangle could easily fold and can come and cover this part of the tetrahedron. So our shape is going to form as a tetrahedron. Now this is what it was about the practice part on page 161. What we're going to have next is going to be a teaching session. So please prepare your copybooks and be ready to take notes. Angles. We're going to start our session by defining an angle. So what does an angle mean? An angle shows the amount of turn between two lines that form a vertex. Angles are measured in degrees. One whole turn is 360 degrees, or 4 right angles. Now, in order to well represent it to you, I would say that you already know that we have a right angle which looks something like this. Now, this is called a right angle. Now, a full turn consists of 4 right angles. So if I have another right angle on the other side, and another right angle following that here, and another one here, so in total I'm going to have 4 right angles. So as you could see, if I go from this part all to the other part, I'm going to have a full turn. So a full turn is actually 360 degrees, which means 4 times 90 degrees, or 4 times right angles. All right, now we're going to talk about the different kinds of angles. According to the measurement of each angle, we're going to classify them and label them with different names. So as different angles, we are going to have an acute angle. An acute angle is less than 90 degrees. So please Be careful. If an angle is less than 90 degrees, let's say 89 degrees or 89.5 degrees, we call it an acute angle. So if I ask you to draw an acute angle, you are free to draw an angle as you wish, but it must be less than 90 degrees. A right angle, on the other side, is an angle which is exactly 90 degrees. And an obtuse angle is an angle which is more than 90 degrees, but less than 180. Now, this is very important. Now, about this 180 degree angle, I didn't want to include this here because I will talk further about it in the last slide, but in order to just give you a clue, now this 180 degree angle is called a straight angle. So we call it a straight angle. 180 degree is a straight angle. So we're going to have acute angle, which means less than 90. The 90 degree itself is a right angle. Between 90 and 180, we call it obtuse angle. And 180 degree itself is going to be a straight angle. Okay. Let's move further on. As you know, in order to measure the length of a line, we use a ruler. Now, we have different tools in mathematics for different purposes. When we talk about angles, what we need, by means of tool I mean, is going to be a protractor. We use a tool called a protractor to measure the angle. So let's say, now here is the point in order to talk about how to use a protractor. So imagine we have an angle. So obviously you could recognize that this is a right angle. But in order to just make sure, and as to make it a practice, I want to measure this angle using a protractor. A protractor looks something like this. Now you might find different variations with different molds and different shapes of protractor, but almost all of them work the same way. In order to find the measurement of an angle, you need to align the center of this protractor to the vertex or the corner of the angle. So this is very important. The center of the protractor should overlay the vertex of the angle. Next one is going to be the horizontal line or the base of our protractor. You need to align this line on the baseline of the angle. Now, what it looks like is this. Now, you have the center here, both of them aligned. Yes. The line of the angle is aligned by the base of the protractor. Check. Now it's time to measure it. Now, this part is very important. As you can see here, we have two zeros, one on the left side and one on the right side. Both of them are our start points. But you might wonder which to choose and start with. Now, this is the important point. Remember this. If you have an angle, imagine it's a face. All right, it doesn't look like a face, does it? All right. And this is the mouth of it. And this part, the angle itself is mouth of it. So actually, if you look at it carefully and use your imagination, this angle is looking rightwards, right? So you are going to use the right zero as your start point. I will explain this one further on, but please, if you didn't get the idea, rewind the video and watch this part all over again. So because my angle is a rightward angle, it looks to the right side, I will start with the right zero as my start point. Therefore, I will say, let's get rid of this, all right. So we will say right zero start, and what will end my measurement is going to be the next line. All right, I got it. Now let's read the number. What does it show? It shows 90. So my angle is exactly 90 degrees. So it is a right angle. Now let's have different variations of angles. What about this angle? Okay, let's say center to the vertex, line to line, everything is correct. Check, it's time to measure. Imagine the face. Is it rightwards? Yes, it is. So we're going to start from the right zero. Starting from here, let's go on. Oops, you need to finish here. Now let's read. Because you started from the right zero, so you will go 10, 20, 30. Some students start from the correct place, but when it comes to reading, they read the other side. Now you need to be careful that this 145 here is the corresponding measurement for the left zero, while we were working with the right zero here. So we will end by 0, 10, 20, 30, and almost 35 degrees. So this angle is going to be 35 degrees. Now you tell me, according to the measurement, is it an obtuse angle or an acute angle? That is 100% true. This is an acute angle. Moving to another example. I think this one is going to be a little bit different. Let's align our protractor and center to the vertex. Lines aligned, yes. Now, what do you think? Is this angle a rightward angle or a leftwards angle? Is it facing the right side or the left side? What do you think? Yes, it is facing the left side. See, imagine the face again. And now this is going to be a very big mouth. You see, it's facing the left side now, while these ones were facing the right side here. About this angle, it was facing the right side, while this one is facing the left side. So we will start from the left zero, right? Let's get started. Left zero. 10, 20, 30, 40. Yes, let's go on. Where it's going to limit is going to be this line. Let's read it. Now, should I read this number or this number? Of course, the upper one, because it is related to the left zero. The inside one is related to the right zero. I don't need. So actually, you could understand it here that in a protractor, we have two start points, right one and the left one. But according to your start point, you should understand which number to read. If you're starting from the right side, you should read the numbers which are in order from the right side, which means the bottom one. But when you're reading from the left side, you should read the upper numbers. Okay then, let's see. I say it's 140 and here is 145. It's something in between. So I say it's 143. So this angle is going to be 143 degrees. So according to our book, our lesson is going to be over here. But as you could guess, I always teach a little bit extra. So let's step further and learn something more. I told you that a straight angle is 180 degrees. At the beginning of the video, I told you that an angle which measures at 360 degrees is a circle which goes full turn. Now, here is the time to know that if an angle measures at 180 degrees, it's going to look like a line. So this line shows the angle which measures at 180 degrees. If I show you the protractor, okay, center to the center, base is aligned. So obviously here we don't have any vertices. We don't have any corners of the angle. So it doesn't matter where you place the center. If you just align the base of the protractor to the line, that's enough. Now you might say, teacher, now what? It's not looking at the right side. It's not looking at the left side either. Well, I say it doesn't matter here. If you either start from the right 0 or the left 0, both of them are should be correct actually. Let's try it. Okay, let's start from the right 0. Let's go on. Finish it here. Okay, what do you see? 180 degrees. All right, let's try the upper one, the left side. This one. Let's go on. Finish it here. What do you see? 180 degrees. So this angle is 180 degrees. Keep it in mind. Now I'm going to show you a little bit of mathematical magic. Let's say we are talking about an angle. Now let's say this inside part of the angle is measured at 45 degrees. And the other part, which means this part, is not measured. And I don't have a protractor either to measure it. So, is there any calculation-based method for me in order to understand what is the measurement of this angle? Could I use my mathematical knowledge in order to find this angle? Think about it, please, before I say it. Well, yes. Here's a hint. I told you this angle is 180 since it's a straight line. So actually you could see that this straight line consists of two parts. One of them is 45 degrees. Whole part is 180. So I'm asking you, if whole of it is 180, this part is 45. What is left for the other part? Obviously, we're going to have 180 minus 45, which is going to give us this part, 135 degrees. And this is how you can play with the angles in mathematics very easily. This was pretty much what we had for today's lesson. Please take your time and watch the video all over again in case you think that you didn't get some parts properly. Take care after yourselves and see you next session. Bye-bye.